Let us solve for the particular solution of this differential equation. Notice na yung hinahanap na for this problem is the particular solution. Ano ba yung difference niya sa general solution? Yung general solution, that represents all the solution of the differential equation. Kung baga sa families of curve, nire-represent niya yung buong family. And yung answer natin doon, that involves the constant c. Wala pa siyang value. Kapag particular solution, that can be obtained with the help of an initial condition or boundary condition. So, kumbaga sa family of curve din, ang nire-represent lang niya ay isang line or isang curve. And yung value ng c is nasa-solve natin or may value na siya. So, let's try solving xy, y prime equals 1 plus y squared. Palitan muna natin si y prime ng derivative of y with respect to x and we'll have xy dy over dx that is equal to 1 plus y squared. So, pagsama-samahin natin lahat ng x and y sa isang side lang. So, i-retain natin si y sa left side and lahat ng x lagay natin sa right side. We can do that by multiplying the whole equation by dx and dividing it by x and 1 plus y squared. We'll have here y dy over 1 plus y squared. And on the right side, we'll have dx over x. So, napag-iwalay na natin yung mga variable. We can integrate. For the left side, gamit ulit tayo or i-represent natin yung denominator as u. So, taking the derivative, du is equal to 2y dy. So, notice na itong term na to, that is the numerator ng original equation natin. So, to get that, we just divide the whole equation by 2. That is equal to y dy. Writing this, we'll have the integral of du over 2 multiplied by the denominator u. That is equal to integral of dx over x. So, integrating, we'll have 1/2 ln of u, that is equal to ln of x plus, so dahil yung first two terms natin ay inside ln, yung constant natin, lagay na rin natin inside ln. By logarithm rules, itong factor na to will be the power of u, and palitan na rin natin yung value ng u ng 1 plus y squared. So, we'll have 1 ln of 1 plus y squared raised to 1/2. That is equal to, and this sum can be expressed as the product of c and x. So, para matanggal natin yung ln, let's raise the whole equation by e. 1 plus y squared raised to 1/2 is equal to square root of 1 plus y squared. That is equal to c multiplied by x. So, yung nakuha natin na yan, that is the general solution. To solve for the particular solution, substitute lang natin yung initial condition na x equals 2 and y is equal to 3. 1 plus y is 3 squared equals c multiplied by 2. So, we'll solve for the value of c, and this is square root of 10 equals 2c. Therefore, c is equal to square root of 10 over 2. So, for the particular solution, isa-substitute lang natin yung value ng c doon sa general solution. And we'll have square root of 1 plus y squared equals square root of 10 over 2 multiplied by x. So, to simplify this further, erase natin yung whole equation by 2 para matanggal yung radicals. So 1 plus y squared is equal to 10 x squared over 4. Multiplying the whole equation by 4, and again we'll get 4 plus 4y squared is equal to 10 x squared. Notice na common factor si 2. Dividing the whole equation by 2 and rearranging the equation na mauuna yung x, the particular solution of this differential equation is equal to 5x squared minus 2y squared minus 2 equals 0. Ang difference lang ng particular solution is may value na yung constant na c, unlike a general solution na as is lang na c yung nilalagay natin sa kanya. Next, let's try to solve for the particular solution of xy squared dx plus e raised to x dy equals 0 when x approaches infinity, y is equal to 1/2. Let's first rearrange the equation kung siya ba ay magiging variable separable. Pagsama-samahin natin lahat ng functions ng x and dx and lahat ng functions ng y and dy. So to do that, let's divide the whole equation by y squared and e raised to x. Dividing the whole equation by y squared and e raised to x, we'll get x dx all over e raised to x plus dy over y squared. That is equal to 0. So napag-iwalay na natin yung functions ng x and functions ng y. We can now integrate to solve for the general solution of this differential equation. For the first term, you can notice na kapag itong denominator is nilet natin as u, ang makukuha lang din natin, pag tinig natin yung derivative is e raised to x dx. So, hindi lalabas yung numerator. So, meaning, hindi yun yung gagamitin nating method to solve for the integral of the first term. Gawin natin, ilagay natin sa numerator yung e raised to x. So, magiging e raised to negative x dx. And for the second term, ilagay na rin natin sa numerator yung denominator. So, magiging negative exponent. So, for this, we'll just use the power rule. And for this, let's use the integration by parts. So, integration by parts is integral of u dv, that is equal to uv minus v du. So, set natin yung u. Tawagin na lang natin yung x. And yung dv, that is e raised to negative x dx. So, derivative of u is du. And derivative nung nasa right side, that will be dx. The integral of dv is v. So, integral nung right side is negative e raised to negative x. Therefore, the integral of x e raised to negative x dx is the product of this, so uv minus the integral of v du. Sulat natin. So uv is x times negative e raised to negative x, or negative x e raised to negative x minus the integral of negative e raised to negative x dx plus, yung second term natin, integral nun is y raised to negative 1 divided by negative 1, that is equal to the constant c, kasi indefinite integration. Evaluate natin ang integral nito. So, pwede natin gamitin to. Negative x e raised to negative x minus that will be positive, and the integral of e raised to negative x is negative e raised to negative x minus 1 over y, that is equal to c. So this is now the general solution of the differential equation. To solve for the constant c, palit lang natin yung initial condition for the values of x and y. So, negative infinity, e raised to negative infinity, minus e raised to negative infinity, minus 1 over 1/2. That is equal to c. Ano ba yung value when e is approaching negative infinity? So, recall, that is equal to 0. So, this is also 0. Therefore, the value of the constant c is equal to negative 1 over 1/2. That is negative 2. So, ipalit lang natin to doon sa general solution. And we now have the particular solution. So, negative x, e raised to negative x, minus e raised to negative x, minus 1 over y, that is equal to negative 2. So, usually when we're writing the final answer, wala tayo nung negative exponents. So, lagay natin sa baba or sa denominator. So, negative x over e raised to x, minus 1 over e raised to x, minus 1 over y, that is equal to negative 2. Usually din, wala tayong denominator. So, multiply natin by the common factor para ma-eliminate natin yung denominators. So, e raised to x and y. We have here now negative xy minus y minus e raised to x equals negative 2 e raised to x y. Then dividing the whole equation by negative 1, we have now the final answer xy minus or plus y plus e raised to x equals 2 e raised to x y, or the particular solution given the initial condition when x approaches infinity, y is equal to 1/2. Solve for the particular solution of x sine y dx plus quantity x squared plus 1 times cosine y dy equals 0, given the initial condition that when x is equal to 1, y is equal to pi over 2. Check muna natin kung itong equation ba na to ay variable separable. So, let's separate functions of x and functions of y. To do that, we'll divide the whole equation by x squared plus 1 and sine y. Dividing this by this term, we'll have x dx over x squared plus 1 plus cosine y dy over sine y equals 0. So, as you can notice, napag-iwalay natin lahat ng functions of x and functions of y. Therefore, this is variable separable. Now, we have to integrate to get the solution. Looking at this term, we can notice na kapag kinuha natin yung derivative nito, makapagpalabas tayo ng x dx. So, let's use substitution for the first term, letting the denominator be equal to x squared plus 1. So, getting the derivative of both sides, we have du that is equal to 2x dx. So, solving for x dx, we have du over 2. So, that is equal to x dx. Palit natin to for the first term. So, the numerator is du over 2. And the denominator, x squared plus 1, nilet natin as u. For the second term, pag tinignan natin, yung numerator is also the derivative of the denominator. So, let us say v is equal to the denominator sine y. Taking the derivative of both sides again, dv is equal to cosine of y dy. So, ipalit natin to for the second term. We have now dv over v. So, mas madali nang kunin yung integral. The integral of du over 2u, that is just 1/2 ln of u plus integral of dv over v is ln of v equals, so again, dahil meron tayo ditong ln, yung ating constant, ilagay na rin natin inside ln. So, palitan natin ngayon yung u ng x squared plus 1 and v ng sin y. 1/2 ln of x squared plus 1 plus ln of sin of y, that is equal to ln of c. So, by laws of logarithm, this factor can be written as the exponent of x squared plus 1. And pwede nating pagsamahin itong sum as product. So, ln of x squared plus 1 raised to 1/2 multiplied by sin y, that is equal to ln of c. And to remove ln sa both sides ng equation, we should take the e of both sides. So, matatanggal natin yung ln. And the result from that is, sulat na natin to as radical. So, square root of x squared plus 1 multiplied by sin y, that is equal to c. This is now the general solution of our differential equation. Kailangan natin ng particular solution. To get the particular solution, we'll just substitute the initial condition, x equal to 1 and y is equal to pi over 2. So, when x is equal to 1 squared plus 1 multiplied by sine times sine of pi over 2, that is equal to the constant c. So, square root of 2 sine of pi over 2 is equal to 1, that is equal to c. So, c is equal to square root of 2. Substituting this to our general solution, that will now be the particular solution. Square root of x squared plus 1 multiplied by sin y, that is equal to square root of 2. So, this is now the particular solution of the differential equation. Kung mapapansin niyo sa solution natin, lagi tayong nagmo-modify ng c instead na isinusulat lang natin siya as a constant c. So, try natin dito na isulat lang natin yung constant as c nang wala tayong gagawing modification sa kanya. So, solving this, nakuha na natin kanina as 1/2 ln of u plus ln of v equals c. So, sulat lang natin siya as constant c instead of ln of c. Substituting u equals x squared plus 1 and v as sin y. And gawin na natin exponent si 1/2 ln of x squared plus 1 raised to 1/2 plus ln of sin y, that is equal to c. Then, pagsamahin natin to, since sum siya, pwede siya maging product by laws of logarithm multiplied by sin y equals c. And tanggalin natin yung ln dito by taking the e of both sides. So, therefore, this term, square root of x squared plus 1 multiplied by sin of y, that is equal to e raised to c. So, this also is a general solution of the differential equation. It's just a matter of simplifying c. So, nakadepende kung paano mo gustong i-present si c, but this is also a valid answer for the differential equation. If we solve for the particular solution of this problem, makikita niyo na pareho lang yung makukuha nating sagot dun sa ginawa natin kanina. So, try natin gawin yon. Palit ulit natin si x na equals sa 1 and si y equals sa pi over 2. 1 squared plus 1 multiplied by sine of pi over 2 equal to e raised to c. So, square root of 2 multiplied by 1, that is e raised to c. And e raised to c, that is equal to square root of 2. Huwag na natin kunin si c, ipalitan lang natin directly si square root of 2 as the value of e raised to c. We can see that the particular solution is also equal to x squared plus 1 or square root of x squared plus 1 multiplied by sine of y equal to square root of 2. So, ganun pa rin yung makukuha natin. Again, it's just a matter of simplifying yung c, pero walang kaso kung isulat mo siya as c or kung ano pang gusto mo, basta mananatili siyang constant.